All right, guys, another polynomial problem. In this one, it says find all the zeros of this big, long polynomial. And to do that, we have to use the rational zero theorem, which says I'm going to find all my p's over q's, which are going to give me possibilities that I can use to use synthetic division to hopefully find all the zeros. So remember, p is going to be all of the factors of our c term, our constant term. In this case, negative 40. So that's going to be what? 1, 2, 4, 5, 8, 10, 20, 40. Over all my q's, which are going to be factors of the leading coefficient. In this case, just 1 and 2. 1 and 2 are factors of 2. So the possibilities here, if I just go through my list exhaustively, 1 over 1 is 1, 1 over 2 is 1/2, 2 over 1 is 2, 2 over 2 is 1, I already have that, so those are done. 4 over 1 is 4, 4 over 2 is 2, I already got 2. 5 over 1 is 5, 5 over 2 is 5/2. 8 over 1 is 8, 8 over 2 is 4, I already have 8, I already have 4. 10 and 5, I need the 10, I already have the 5. This is going to be 20 and 10, so I just need the 20, I already have the 10, and that's going to be 40 and 20, so I just have the 40. All right, then what we're going to do with this is we're just going to exhaustively go through this list using plus or minus all of these numbers, and hopefully something will divide into this nicely. So this could take a while. So I'm going to write out a little synthetic division chart here using my coefficients 2, 17, negative 2, negative 85, and negative 40. All right, let's just start with 1, and we'll work our way up the list. All right, so if I try 1, that would be what? 2 times 1 is 2, 17 plus 2 is 19, 19 times 1 is 19, it's back to 17, 17, 68, and that does not work, right? We need this to be a 0, and that would be 28. Okay, so that does not work. All right, let's try it again. This time we'll try negative 1. See if negative 1 gives us any better results. Be a 2 still. 2 times negative 1 is negative 2. Down to 15. Negative 15. So negative 17, positive 17. 68 again, negative 68. And that would be positive 68. Again, this gives us 28. Does not work. We need that to be a 0. Okay? Keep working down our list. Keep working down the list. So after 1, positive, negative 1, I can cross that out. Let's try 1/2. Let's try 1/2. Again, bring down 2. Half of 1/2, or half of 2, I should say, is 1. That's 18. Half of 18 is 9. Bring this down. 9 minus 2, 9, 8, 7. 7 halves. Ooh, this is going to get ugly. 7 halves. And then I'll show you here that once we bring this down, this is going to be, again, something over 2. Then multiply that, we're going to have something over 4 at the end, which will not give us a 0. So we can stop that one right there. So positive 1/2 does not work. Okay. What about negative 1/2? What about negative 1/2? Bring down 2. Half of 2, or negative 1/2 of 2, I should say, is negative 1. 17 minus 1 is 16. Negative 1/2 of 16 is negative 8. That's negative 10 if you combine those. Negative 1/2 of negative 10 is a positive 5. Negative 85 plus 5 is negative 80. Ooh, this one might work. And then negative 1/2 of negative 80 is a positive 40, which, yes, if you can combine those, we get a 0. All right. So let's see what we have left here. We have our constant term, our linear, quadratic, and cubic terms. So we have 2x to the third plus 16x squared minus 10x minus 80. And we know that negative 1/2 is a 0. So what happens if maybe I can factor this by grouping. Is that going to work? I think it is. Factor this by grouping. Take out a 2x squared. Leave me with just x plus 8. in order to get x plus 8 over here, I need to take out a negative 10. X plus 8. So it's leaving us with 2x squared minus 10 and x plus 8. All right. We want the 0, so I do have to set these equal to 0 and solve. On this one, that would be 2x squared, move that over, equals positive 10, divided by 2, x squared equals 5, square root. So x equals plus or minus root 5. So those are two of my zeros. I also am going to have x plus 8 equals 0, so x equals negative 8. And I need 4, right, because this is a degree 4 polynomial. And my fourth one, if this is 2, 3, my fourth one is actually going to be negative 1/2. So x equals negative 1/2. Those are the 4 zeros of that big, long